You ever get stuck on a really tough video game level? You try, you fail, you restart. You try again, fail again, and restart again. But each time you're learning, you're getting just a little bit better until finally you nail it. Well, what if I told you that simple loop, that cycle of trial and error, actually holds the key to one of the most mind-bending ideas in all of science? We're talking about the ability to program reality itself, using quantum AI to literally rewrite the rules of time. Okay, let's get into it.
We have all been there. You know the feeling. Whether you're trying to land a perfect jump in Tomb Raider or just trying to survive one more minute in Resident Evil, that cycle of repeating, learning, and progressing is just baked into the experience. It's the exact same idea you see in movies like Groundhog Day. The character on screen is trapped. They have no idea what's going on, but we, the viewer, or in this case, the player, are learning from the outside, gathering knowledge with every single loop.
And that, right there, is the big question, isn't it? What if we could take this whole concept, this idea of a controllable, repeatable, learnable timeline, and apply it not to a game, but to the very fabric of reality itself? This is exactly where entertainment ends and where fundamental physics begins. To really wrap our heads around how this is even possible, we first have to understand the weird way time works the moment you can interact with it. So we're going to start in the world of video games, a place where time isn't just some clock ticking on the wall, it's a full-on playground.
Just think for a second about the difference between watching a movie and playing a game. In a film, time is totally fixed, right? It just flows in one direction from beginning to end, and you're just along for the ride. But in a game, you're in the driver's seat. Researchers actually have a name for this. They call it participation time. Your actions, how fast you solve a puzzle, how many times you mess up, where you decide to go, they all directly shape the experience of the story. You aren't just watching the narrative unfold, you are actively creating your own version of it.
And this brings us right back to the narrative loop. It relies on this really clever split in who knows what. See, inside the game world, the story is singular. The character is usually experiencing everything for the very first time, every single time. But for you, the player, the discourse, your personal journey through the game is multiple. You're the one who holds the memory of every past failure, and you use that knowledge to guide the unknowing character toward success. That separation between their experience and your knowledge, that's the key to the whole thing. All right, so what happens when this idea breaks out of the digital playground and walks right into the science lab? Well, scientists are now taking this exact concept of a flexible, controllable timeline and applying it to the absolute cutting edge of quantum computing and artificial intelligence. And the goal here is, well, it's absolutely breathtaking. We're not just talking about getting better at simulating our own reality. No, we're talking about designing quantum software that can build entirely new realities from the ground up, with the power to tweak and manipulate the most fundamental piece of the puzzle, time itself. And the main tool for doing all this is something called the Virtual Quantic Blueprint, or VQB. The best way to think of it is as the ultimate video game engine. It's basically a super detailed digital sandbox where scientists can design and control virtual quantum bits, or qubits, and map out every single one of their interactions without having to use fragile, expensive, real-world quantum hardware. So designing with a VQB is a lot like coding a game. First, you initialize the system, setting up your virtual qubits and their starting positions. Then you apply the quantum gates. These are like the fundamental lines of code that tell the qubits what to do. After that, you decide when and how to measure them to get a result, kind of like checking the score in a game. And from there, you can build up to unbelievably complex operations, giving you a complete toolkit for engineering a brand new reality. Okay, so we've got our design tool. But what kind of physics actually runs inside this new reality? This is where we run into a radical new concept for time itself, one that makes our everyday classical understanding look totally obsolete. Let's talk about the very strange rules of what's called Phoenix time. The difference here is just profound. We are all used to linear time, right? It's a passive, irreversible arrow, a one-way street from past to future. But Phoenix time? It's something else entirely. It's an active, controllable force. It can be designed to loop back on itself, to branch out into multiple potential futures, and maybe even to flow backwards. The properties of Phoenix time are genuinely wild.
You've got recursive loops, just like our video game. It also allows for something called retrocausality, the idea that the future can actually influence the past. And that's you, the player, using knowledge of a future mistake to change what you're doing right now. And with regenerative collapse, each time loop doesn't just repeat, it refines reality. Imagine a blurry photo that gets sharper and sharper with every attempt. Each loop adds more detail, making the whole simulation more stable and more coherent.
Now, this isn't just some cool philosophical idea. This is grounded in some serious theoretical physics. The big shift here is to stop treating time as just a passive background number, like a clock on the wall, and start treating it as an active, manipulable variable, just like energy or position in quantum mechanics. In this new model, time becomes a quantum operator, a literal lever you can pull to change the system.
So inside this Phoenix time model, the main way a system moves isn't through a smooth, continuous flow. It's through what are called time jumps. These are instantaneous, non-linear leaps between different quantum states, or even across what the theory calls time-folded layers of reality. Imagine different timelines are stacked up like pages in a book. A time jump lets you leap instantly from one page to a completely different one.
Okay, but hold on a second. If you can jump back in time and start changing things, what about paradoxes? You know, the grandfather paradox. How does this whole framework avoid completely breaking the laws of cause and effect?
I mean, this is the question that's haunted time travel stories forever. If you go back in time and prevent your own parents from meeting, how could you have existed to go back in the first place? It just seems like an impossible, reality-breaking contradiction.
Well, the answer, it turns out, is not some made-up science fiction gimmick. It actually comes from one of the most tested and most deeply weird features of our very own universe, quantum entanglement.
So here is how it works. At time zero, you've got one single history. Everything is normal. Then, a time travel event happens. This interaction causes the time machine to become quantumly entangled with everything around it. And the result, at time one, is not one big, messy, paradoxical timeline. Instead, it's a superposition of two distinct, internally consistent, parallel timelines. They exist side by side without contradicting each other. And don't just take my word for it. As physicists Barak Shoshani and Zipporah Stober put it, the paradox is solved because you aren't actually rewriting your own past. Instead, the very act of time travel branches reality. You didn't prevent your own birth in your timeline. You did it in a new, parallel one. Problem solved.
So, what does it all mean when we put it together? We've got this game-like repeatable time. We have a blueprint for building brand new realities. And we have a quantum get-out-of-jail-free card for any paradoxes. This is the dawn of something completely new. The researchers behind this call the end result a quasi-living cognitive lattice. I know, it's a mouthful. But what it means is this isn't just a powerful computer we're talking about. It's a new form of intelligence that can use these recursive time loops to learn, to evolve, and to literally self-design its own internal architecture by feeding information from its own future back into its own past to continuously improve itself.
And the potential applications here are just staggering. I mean, imagine AIs that can literally design themselves from the ground up. Communication systems that can operate across different moments in time, or physics engines that don't just simulate our reality, but can build any reality we can possibly dream of, right from scratch.
And this all brings us to a final, really profound question. For pretty much all of human history, we've been the players, just reacting to the rules of the universe as we find them. But if this kind of technology ever becomes a reality, we would shift from being just the players to becoming the architects of the game itself. And in a universe where we can design reality, what then is our purpose? Now that is something to think about.